Hello class, welcome to our lesson today dealing with section 9.1. We're going to start to look at volume and surface area of different objects, three-dimensional pieces, this chapter. We're going to use the area formulas that we used in chapter 8 in order to help us find some of these answers as well. Before we get too far into the surface area of prisms today, I'd like to review a few things about percentages. I used some with the percent equation and some with the percent proportion as I looked through these examples. The first one I did the equation, what is x equals, change 35% to 0.35 and then times 210. You multiply those two things together and you get x equals 73.5. I also did the equation on this top right one, 38 is equal to 0.24 or 24% of the x value. And then I divide by 0.24 on both sides in order to figure out that x equals 158.3 repeating. Depending on the situation, you might write that as a fraction of 1/3. You might have to round that. Kind of depends on what the question is looking at, but that's the exact answer in order to find for that question. And this last one, I did the percent proportion. So I said 22 is what percent of 200? So that'd be 22 out of 100, and then equals x over 100. And I would cross multiply and solve, and you get 11. You could also divide by 2 here, and you get 11 out of 100 very quickly, because being out of 200, you can get to 100 by just division by 2. Okay, what we need to talk about here with surface area is what's known as a net, and also how to kind of find surface area. What I don't want you to do is just memorize every single version of a surface area formula. And honestly, that probably wouldn't be given to you on any reference page anyway. It is true that the surface area for a rectangular prism or a box is 2 times length times width plus 2 width height plus 2 length height, which essentially says there's a front and back, okay, they're the same. There's a left and right side and they're the same, and the top and bottom and they're the same. The reason I would not suggest just memorizing formulas is what if there's no top or no bottom? You might just be better off just multiplying the areas and adding them together. A net is a 2D version, so it's like you flatten it out like a cardboard box kind of, and flatten it out and say, what would it have to look like, and then where do I fold it to make the 3D object that would be a rectangular prism? For some of you, this idea is very easy to draw out. You don't have any trouble figuring out what the net would look like. For others of you, this is hard to see, so to visualize, the idea is like these two fold up at the top and bottom, the left and right fold, so that makes the box, and then the top has to wrap all the way around to become the top piece of the object. This one's kind of from the front perspective, so you see height and width, that's this piece right here, so it kind of folds in on itself this way, and then the tops fold down. But you're going to have to draw some nets for the rectangular prism, and you need to label the length, width, and height kind of in there at least one spot as you're looking at that situation. The next one is what's known as a triangular prism. Now this is a little bit harder to see, but what you'll notice is there's 3 rectangles kind of around the edge, and then the 2 triangles fold down. The reason, if I'm skipping kind of to part B real quick, this is a triangular prism because the top and bottom, the 2 bases are triangles, and then there should be rectangles around that connect them. So it doesn't matter that the fact that there's rectangles, don't call it a rectangular prism, because a box is already a rectangular prism. So this is a triangular prism because the 2 ends, the 2 bases, are triangles. Now, this is where the formula idea becomes important. Don't memorize a formula for triangular prisms. Okay, just think about it. There's a rectangle here that's 3 by 3. There's a rectangle here that's 5 by 3, and a rectangle here that's 4 by 3. But there's only one of each of those, so you don't have to double them. That's where these 3 pieces come from. And then the top and bottom are 2 triangles that are identical, so you could double that. But you want to do length times width or base times height divided by 2. But you have to make sure that that's the right angle. So I don't think you need this 5 here to find the area of this triangle. So 3 times 4 divided by 2 is 6, times 2 would be 12. Some of you are going to say, well, why even divide by 2? Well, the reason to make sure to think about that every time is because what if there's no top or bottom to it? You may only have one triangle, and then you'll have to make sure you divide by 2. And then you add up all of these pieces, you get 48 square units. It's area, so it's units squared. And that would be how you find the surface area of the triangular prism, like this picture. The reason the surface area becomes important in application is things like wrapping presents, or this example is a good example about ice blocks melting. The idea is that the more surface there is, the more that the sun can hit or the temperature can hit the object. So this is no different than like outside when it snows. Okay, snow will melt fairly quickly if you just have a little bit of it, like on the sidewalk, for example. But if you have the big mound of snow, like from a snowplow that's moved snow off to the side, that big mound's going to last a long time because its surface area is much smaller. Okay, so the idea here would be that this larger block of ice is not going to melt as fast because its surface area is less than these 3 cubes, because essentially you've sliced it into 3 pieces and there's more surface that it will melt faster. So the smaller surface area will take longer to melt versus the 3 smaller blocks that have a larger surface area will melt a little bit faster. All right, so your book does give you a formula for a rectangular prism surface area. Remember, you're never going to get a formula for surface area. You have to understand kind of where it comes from in order to find some of those solutions. That's the same case in things like standardized tests, for example. There typically aren't formulas given for rectangular prism surface area because it's just area of objects. Notice that it's 2 of the length width, 2 of the length height, 2 of the width height. There's also something called the lateral surface area. Now, the lateral surface area is everything but the 2 bases. Now, sometimes it's hard with a rectangular prism to find the bases because you're not sure if these are the base or these. If they don't tell you, assume the bases of a rectangular prism are the top and bottom. Okay, so you want to assume that piece as you're looking at those questions. If it's a triangular prism, it's guaranteed that the triangles are the bases, even if it's tilted on its side. So that's something to look at too. The lateral surface area is the area of all the lateral faces or the sides of the object. The lateral areas, like wrapping a present or the idea of like a label around a can, something like that, okay, those types of things are lateral areas. So you have to think about wrapping things, okay, kind of around the sides of the object, okay, or painting an object. Things like that are how surface area and lateral area can be looked at. Okay, for this question, you just have to draw the net and find the surface area. I bring up the draw the net piece because your book typically doesn't say to draw the net, but my request and expectation is that you're going to draw the net for a lot of these questions, at least in these first couple sections, in order to get full credit for your assignments. Notice here that I have 11 by 6. I'm just going to draw this 11 by 6 one right here, and then kind of unwrap it. Okay, so there's 11 by 6, and then 2 11 by 5s next to it, and then another 11 by 6. The key is you can't put the 2 11 by 5s right next to each other. So some students mess this up and say, oh, this is 6, then 5, 5, and 6. They have to be kind of opposite of one another as you're looking at that. I know to find the surface area, you don't have to draw the net, but that's both skills we need to work on here. So 2 length width, 2 base length height, 2 width height. Add all that together. I need to see the setup in order to get full credit for these questions. What I don't want to see is number 1 is 302. That doesn't help us see what the numbers were. So you need to make sure that you're showing where those numbers came from and how to set them up in order to get full credit for those situations. Your homework today is questions 1 and 2, 7 through 9, and 29 through 32 of section 9.1. You really want to focus in on 7 through 9. They need to look like this scenario. So you got to show the net, show some work, and then find the answer. You can plug that into your calculator, but you got to show a setup at least in order to figure out the surface area and draw the net of the objects. We're going to be looking for that specifically on 7 through 9. Questions 1 and 2 you can find in your textbook. They're just kind of vocab pieces that you can look in the beginning. And if you have questions on 29 through 32, it also says what section those questions are from. Have a good day, everyone.